so we are going to be working on endo and exothermic reactions again. And we're also going to be talking about breaking and forming bonds, and we're actually going to be drawing those ionic and covalent bonds again. So make sure you remember how to do those as well. So if you guys want to open up your assignment for today on bond energy and breaking and forming bonds. All right, it should look just like this one. All right. So before we can go into any details, we do need to remember how to identify between endothermic and exothermic reactions. So can anybody tell me what an endothermic or exothermic reaction is? I can do. Awesome, awesome, awesome.
Endothermic absorbs the energy.
All right, endothermic absorbs energy and heat, which means exothermic, I think somebody said it in the chat, releases energy or heat. All right, so now I want you guys to take about 2 minutes to go through A through E and determine if it's endothermic or exothermic based on our knowledge of endo and exothermic reactions. So just go through and write endothermic or exothermic for each of those. We'll come back as a class in a minute to go over them. All right, so let's look at 1A first. When two chemicals mix, their temperature rises. Is that endothermic or exothermic?
Endothermic.
Endothermic. Why would you say endothermic?
Because they are absorbing like the energy from the temperature.
All right, so they're absorbing the energy and that's why the temperature rises?
Yeah.
All right. So I like the fact that we're talking about the temperature rising, but it's actually going to be exothermic because if we remember back when we talked about the beginning of endo and exothermic, endothermic absorbs energy or heat, which means that it takes in that energy from the surroundings. So if it's taking in the energy from the surroundings, that means it's stealing all of that heat or energy from the surroundings and giving it to the system. So everything outside of that system is going to feel colder. Now the opposite's going to happen with exothermic. It's going to release the energy to the surroundings. And if it releases it to the surroundings, that means it's going to make everything outside of the system, outside of that object or reaction, it's going to make everything else feel hotter or warmer. So if the temperature is rising, it means that that reaction is releasing that energy to make that temperature increase. So it's actually going to be exothermic here because it's releasing the energy, making that temperature increase. Does that make sense? Any questions on that one? All right, letter B. A solid burns brightly and releases heat, light, and sound.
Exothermic.
Exothermic, good, because it's releasing that heat, light, and sound. Heat, light, and sound are all forms of energy, which means it's releasing the energy. When two chemicals are mixed, the temperature drops. What is this one?
Endothermic.
Endothermic, perfect, because it's the opposite of question 1. It's endothermic because the temperature is dropping, which means the reaction absorbed all the energy, making this temperature drop. Letter D, two chemicals will only react if you heat them continually. So if you continuously heat them, they react.
Endothermic.
Endothermic, because and it's endothermic because they only react if you continually reheat them, excuse me. When you continually heat them, they react. And if you keep adding in that temperature, you keep adding in that heat, that reaction's absorbing that heat or that temperature to make this reaction happen, which means that it's absorbing the energy or it's endothermic. And letter E, plants take in light energy for photosynthesis.
Endothermic.
Endothermic again, because it says taking in, good. So it's endothermic because it's taking in that light energy, which means it really absorbs that light energy to make for photosynthesis. Are there any questions on A through E? All right, so the next part of the problem says that we're making and breaking bonds here. So now we're going to be talking about forming and breaking bonds and how energy is absorbed and released when doing that. So it says during chemical reactions, the bonds between atoms break and new bonds form. Energy must be absorbed to break bonds. So breaking bonds is endothermic. Making bonds is exothermic because energy gets released. So forming bonds is exothermic. So then when we're looking at this, it says the green copper carbonate decomposes. The equation is, so real quick, this right here, the CO3, CuCO3 is actually right here. It was just messed up on the writing. So this is our copper carbonate. And if we're looking here, there's a bond between here, this is our copper, and this is our carbon. And then the other bonds are going to be between the carbon and our oxygen. So how many bonds do you see on this copper carbonate?
3.
So there's 3.
4.
So there's 1, 2, 3, 4 bonds. So there's going to be 4 bonds on this copper carbonate. And then we have CuO, so copper oxide right here. So this is our copper still and our oxygen. And how many bonds are there between our copper and oxygen?
1.
Just the 1. And then we have carbon and 2 oxygens. How many bonds are there between our carbon dioxide?
2.
2. Perfect. All right. So now that we've identified where our bonds are, let's identify where our bonds are going to be formed or broken. So if we look at this one, are we forming or breaking bonds here on the reactant side?
Forming.
Careful, this is already a compound, it's already together. And we're going to make something new. So are we going to form these bonds or are we going to break these bonds? We're going to break these bonds. In order to do that, we are going to draw some squiggly lines in between the two compounds, showing that they are breaking. How many bonds did we break here?
4.
We broke 4 bonds. So let's write that right here. 4 bonds broken. All right, that's our reactant side. Our product side. How many bonds were formed on this compound, copper oxide?
1.
We formed 1 bond. And how many bonds were formed on our carbon dioxide?
2.
All right. So how many total bonds did we break?
4, right?
We broke 4 bonds. Perfect. Just this first one. So we broke 4 bonds. And how many did we form or make?
3.
We only made 3 bonds. We only formed 3 bonds, which means, do we think this overall reaction is going to be an endothermic reaction or an exothermic reaction?
Endothermic.
Endothermic, because we broke more bonds than we ended up making in the end.
I have a question.
Mm-hmm.
Why did we break bonds for the first one? Was it because like of the middle carbon?
Why did we break these bonds?
Mm-hmm.
Because we wanted to form new bonds between our copper and oxygen, which is why we had to break our bonds in order to form the new ones in our compounds in the end.
Oh, so the arrow is like saying like we're breaking up those bonds.
Yep, this
'Cause
squiggly
they're
line.
adding different ones.
Mm-hmm. Exactly.
Okay.
So this is endothermic because 4 bonds were broken and only 3 bonds were formed. So let's actually take a look at this problem in terms of what it actually looks like. So if we go, I'm just going to go to the internet. The sound really doesn't matter for us. I couldn't figure out how to get rid of it. But if we watch the video of this happening, all right.
There are many indications.
So up there, the solid inside that test tube sitting sideways is going to be our copper carbonate.
We have some blue-green copper 2 carbonate that we're going to heat. The copper 2 carbonate.
And if you look, he's adding heat continuously, which we talked about before, being a reason we can tell that it's endothermic, because he has to continually add that heat for this reaction to happen. So you can see that it's happening because inside that test tube, you can see that copper oxide is going to be that black-brown substance that you can see inside the test tube where the green-blue substance used to be. So you can see that it's happening because of that color change. And you can also tell that it's endothermic because that heat is continuously added to the system, meaning that it's continually heating up, making this an endothermic reaction. Are we okay with that? All right, so if we keep going and we look at this one. So now it says we have to draw the diagrams to show what happens when methane is burnt. Mark the bonds broken in blue and formed in red. So we're actually going to change that up a little bit, but first we do need to draw our compounds. So let's draw this CH4. So I'm going to draw the parts down here we have carbon and hydrogen. So we need to draw out our carbon and hydrogen. We have 4 of them. And how many valence electrons does carbon have?
4.
It has 4 valence electrons. So let's put our 4 valence electrons on carbon. And how many valence electrons does hydrogen have?
1.
It has 1. So each one is going to have 1 valence electron. And now, do we share valence electrons or do we transfer valence electrons between carbon and hydrogen?
Transfer.
Careful, if they're both nonmetals, because
Share.
carbon and hydrogen are both nonmetals, what are we going to do with them?
Share them.
We're going to share them. And so we show that they get shared by circling the 2 that get shared together. And so now we're going to draw it up here. So we have carbon with 4 bonds to 4 different hydrogens. Plus our oxygen, so O2. So I have 2 oxygens. How many valence electrons do each oxygen have?
1. Oh no, 6.
6, perfect. So 1, 2, 3, 4, 5, 6. All right. So how many bonds does this do each oxygen need to form?
2 bonds.
They need to form 2 bonds. So we're going to form 2 bonds between the oxygens, creating a double bond between our oxygens, leaving the other 4 valence electrons or the lone pairs still on the sides. And we have to add 2 of them because there are 2 of them in our equation. Is everybody okay with this so far? Because here's where it gets tricky. Our next step is going to be to show that our bonds were broken. I'm going to use green just because it's a different color. And to show that our bonds are broken, we're going to put squiggly lines through each of the broken bonds. So I've broken all those bonds. My next step is going to be to show where the new bonds were formed or the new bonds are going to be formed. I'm going to do that in blue. And if we look, we have CO2 and we have H2O. So I'm going to form my CO2. So my carbon is going to form a bond with 1 oxygen, and it's going to form another bond with a second oxygen. I'm going to use dotted lines to show that it's forming a bond between each of those oxygens. And then it's H2O, which means there are 2 bonds, 1 bond from each of my hydrogens to my oxygen. So 2 hydrogens go to each of the other oxygens. Showing that those new bonds were formed. The last thing we need to show is where energy would have been absorbed, or released. So is energy absorbed or released when we break bonds?
Released.
It's released when we break bonds.
It's absorbed.
It's going to be absorbed when we break those bonds. So breaking those bonds absorbs the energy right there. I'm going to show this in red, showing that energy gets absorbed. That's going to be arrows coming into each of the bonds, showing that those bonds are going to absorb energy. So each bond that absorbed energy or each bond that broke is going to have an arrow coming in, showing that that bond was absorbing energy to break it. Are there any questions so far? All right, so now we actually have to draw those bonds that we created from here, the bonds that we showed forming. We actually have to draw those. So let's write those out. Let's actually determine what the bonds look like for our compound. So we have oxygen, carbon dioxide. So 1 carbon and 2 oxygens. How many bonds is this oxygen going to form?
2 bonds.
All right. How many bonds is this oxygen going to form?
2 bonds.
How many bonds is my carbon going to form?
4 bonds.
4 bonds. So do my bonds happen between my oxygen and oxygen, or oxygen and carbon?
Oxygen, carbon.
Oxygen and carbon. So we're going to show the sharing of electrons between oxygen and carbon, creating 2 bonds shared between the carbon and each oxygen. So we have carbon in the middle with 2 bonds, 1 on either side. Plus we have our H2O. So we have 2 hydrogens and 1 oxygen. All right. How many bonds does this hydrogen want to form?
1.
And what about this hydrogen?
1.
So how many bonds is each hydrogen going to form between the hydrogen and oxygen?
2.
We're going to have 1 between each for a total of 2 bonds. So we have our H, O, H. And we have 2 of them. So we have to draw 2 water molecules. And so we have 2 more things to look at. Instead of forming 1 bond between our carbon and oxygen, how many bonds do we have to form for our CO2? How many bonds do we form between our carbon and 1 oxygen?
2.
We form 2, so we have to show the formation of 2 bonds by adding a second dotted blue line to each oxygen, showing 2 bonds got formed, not just 1. Showing all the bonds being formed over here. And then we have to show our energy being absorbed or released on our product side. So is our energy going to be absorbed or released over here?
Release.
Release. So we're going to draw an arrow coming out of each of our bonds, showing the release of energy from our bonds being formed. Any questions? So now if we look at part C has us complete the table showing the number of bonds broken or formed. How many bonds did we break with our carbon and hydrogen?
4.
We broke 4 bonds over here. How many bonds did we break between our oxygens?
2.
We broke 2 bonds between our oxygens. How many bonds did we form between our carbon and oxygen?
2.
We formed 2. And how many bonds did we form between our hydrogen and oxygen?
2.
Careful for this one.
Oh,
How many
4.
bonds? 4. All right. So based just on the number of bonds broken or formed, can we determine if this reaction was endothermic or exothermic? I'm going to take your silence as a no, and I'm going to say that's correct. So instead of just looking there, we actually would see that in this reaction, when it says it's burnt, if it's burning, what does that burning tell you?
It's absorbing energy.
If it's burning, it's absorbing energy. So let's actually take a
releasing.
look and let's see. Let's look at this one happening. So let's click on this one. This one was good. All right. So we're going to take a look after this ad goes away.
What? This spot stinks. They have it easy.
All right.
Well, the only thing more dangerous than Steve Spangler on a Monday is
All
whatever.
right. So we're going to skip ahead and go to the actual point
There you go.
where we
everyone.
have
Hey,
our
you know what, this
methane is going to be those bubbles. So methane is those bubbles right here. It's in that balloon right now. But if you want to know methane, you guys, if you have a stove gas top for a stove, if it has gas in it, that's going to be methane. The gas that we use in school when we use Bunsen burners, that's going to be methane gas as well. So it's CH4, that's the methane. And then the oxygen that he's going to use is going to be the lighter. She's going to actually put it in her hand.
Would you scoop them up for me, Kim? Scoop it up. Hold your hands right there. Nice wide shot. 3,
And
2,
so
1.
you guys saw,
Oh.
It's over. Yeah, I'm leaving. I'm gone.
so you guys see, you saw that it was lit on fire. So do we think that's exothermic or endothermic?
Nice wide shot. 3, 2, 1. Oh.
What do we think?
You're okay.
Okay, didn't even look.
I know.
Okay.
Isn't that okay? You're fine.
Do we think that was endothermic or exothermic?
Endothermic?
Um,
It was exo, cuz.
exothermic, perfect, because it released that energy or released that heat. When it was lit on fire, you actually saw the heat going away because of the flame. The flame showed that it was getting hotter in the surroundings or was burning up. The energy was being released. So there was more energy released than there was absorbed. So that reaction is an exothermic reaction. Are there any questions on part B or C? All right, then you guys have part D to try on your own. Make sure you are drawing the molecule. You are drawing the breaking of the bonds. You are drawing the formation of new bonds, and you are drawing the energy absorbed and the energy released.